Hey everybody, welcome. Today's video we're going to talk about the next lesson in our chapter, and this is all about angles in other types of shapes. Like so far this chapter we've done a lot of stuff with triangles, and we've used the number 180 a lot because the three angles in a triangle always added up to 180 degrees, and then sometimes whenever we were talking about supplementary angles or two angles that made a straight line, or linear pair of angles, all those numbers also added up to 180 degrees. But it's not always going to be like that. For example, students already know for the most part that a triangle adds up to 180 degrees, but what about other shapes, right? What are the degrees in a rectangle add up to, or an octagon, or a hexagon, or any type of shape, right? And instead of just memorizing the numbers, like most of you have memorized that there's 180 degrees in a triangle, we need to have a formula so that way you don't just have to memorize everything, right? Oh, my teacher told me it's this, so that must be right. No. There's an actual formula that you can use to figure out the sum of the interior angles in any type of shape. So instead of just having to memorize it, here's what it is. You take, N stands for the number of sides that the shape has, minus 2, and then you take that number times 180. So for example, if we were going to do a shape that had 7 sides, a heptagon, right? If something has 7 sides, we would do 7 minus 2, which is 5, right? So we would end up doing 180 times 5. And you could obviously use a calculator to help you, but that is 900 degrees. So the angles inside of a 7-sided figure, which we call a heptagon, would add up to 900 degrees. And that works for any number of sides. It doesn't have to be 7, right? If it had 10 sides, we would put a 10 right here. 10 minus 2, which is 8. 8 times 180. If it had 20 sides, we would do 20 minus 2 times 180. If it had 300 sides, right, you could do 300 minus 2 times 180. So whenever they ask you for the sum of the interior angles, what do all the angles inside of a shape added together equal, this is the formula you will use, the number of sides minus 2 times 180. And a calculator is going to be really helpful. Use a calculator on your phone, calculator on your computer, a calculator you have with you. So let's go ahead and skip this one for now. So in case you forgot the names, right? 3 sides, triangle. 4 sides, quadrilateral. 5 sides, pentagon. 6 sides, hexagon. 7 sides, that's the one I just did, heptagon. 8, octagon. 9, nonagon, or some people say this, anagon. It's kind of a weird word, that it has 2 different possibilities. And then 10, decagon, like a decade is 10 years. So if I was going to do triangle, right, 3 minus 2 times 180. Remember our formula, the number of sides minus 2 times 180. Right? That's 180 degrees. If it was a quadrilateral, 4 minus 2 times 180. If it was a pentagon, 5 minus 2 times 180. And I could go all the way down. Hexagon, 6 minus 2 times 180. Heptagon, the one I did just a minute ago, 7 minus 2 times 180. Octagon, 8 minus 2. Nonagon, or the anagon, is 9 minus 2. And then finally the decagon is 10 minus 2 times 180. And you could use a calculator to work all those out. I'm not going to take the time to do it right now. Calculator would be able to knock that out in no problem at all. Now, what if it's higher than 10, right? Because we have nice names for anything that goes up to 10, but for anything that's more than 10, they'll just call it like a 12-gon, or an 18-gon, or a 37-gon, or a 62-gon, right? They'll just use the number to tell you how many sides, because it's not like they have a name for every single one that they want you to memorize. That would be a little bit ridiculous. So here's some practice ones. Find the sum of the interior angles. The sum, that's all of them added together, interior, inside. And so we've got our formula. I remember it. It's right up, it's actually right here. I'm looking off camera. But number of sides minus 2 times 180. A hexagon, in case you forgot, off of my poster, or for that last little chart, a hexagon has 6 sides. So for hexagon, I'm going to do 6 minus 2 times 180. 6 minus 2 is 4. So I'm going to do 180 times 4. And if you can't do that in your head, I don't blame you. But I think I can, just because I've done this for a long time. 720 degrees. An octagon, how many sides does an octagon have? 8. So I'm going to do 8 minus 2 times 180. 8 minus 2 is 6. 180 times 6. I'm going to do my best to do that one in my head. I think it's this, 1,080 degrees. You could use a calculator. I don't want anyone in here having to do all this in their head. Now look, here's what I'm talking about. There's no name for 15-gon, so let's call it a 15-gon. That means it has 15 sides. And so you'll do 15 minus 2 times 180. And so 15 minus 2 is 13. 13 times 180. Now I might actually need the calculator now. So I would do 180 times 13. Oh, geez. I'm going to go old school here, guys. Sorry about this. If this confuses you, I apologize. But I don't have a calculator with me. It's downstairs. Did I do that right? 13 times 180? I feel like I did that right. 20,000? No, there's no way that's right? I did an extra row. What an idiot. I told you I would mess this up. Why did I do a third row like a moron? 0, 4, 3, 1. There we go. 2,340. You can see why a calculator is definitely recommended so you don't make any goofy mistakes like I just did. And then another one, a 31-gon. Now this one's going to be pretty intense. 31 minus 2 times 180. 31 minus 2 is 29. So this is 29 times 180. We're going to see if I can do this one without messing it up. Okay, 0, 2, 7, 16, 0, 0, 6, 3. Why do I feel like this is not right either? Oh, geez. Okay, I'm going to give that one a try. 5,220 degrees. Obviously, if you have a calculator at home, you can check me. That looks like it's about right, though, because 15 is about half of 31, and that is about half of that. So I'm going to hope that that's right. So that's what you'll do today when it asks you for the sum of the interior angles, all the angles added together. Now, what if they just ask you for one interior angle in a regular, whoops, wrong board. Give me 1 second, guys. What if they ask you for one individual angle in a regular, that's a very key word, regular shape, whichever shape it is, a regular triangle, a regular octagon, a regular decagon, right? This word regular, it doesn't just mean what it means whenever you're speaking normally. In math, the word regular means all the sides are the same, like equilateral, you know what I mean? A regular triangle is called an equilateral triangle, right? A regular quadrilateral is where all the sides are the same, which we call a square, right? All four sides are the same. All sides are the same, and if all the sides are the same length, all the angles are the same as well. That's a big idea in geometry. So I could use the word congruent as well. So whenever they say regular, they mean a equilateral shape, right? All three sides are the same if it's a triangle. All four sides are the same in a square. In a pentagon, all five sides in the pentagon are the same. And all the angles are the same. So not just are all five sides the same, all five angles are the same. And so if all the sides are the same and all the angles are the same, you don't have anything that's different. Everything is the exact same measurement, all the angles inside, right? So something like this type of a triangle is not a regular triangle because you have like 90 and that's like really tiny and that one's really tiny as well. A regular triangle looks more like this, where all three sides are the same length. They'll use that little mark. And then all three angles, they'll use this little thing to show you that all the angles are the same. So this is not going to work because those angles are different. But here, all the angles are the same because all the sides are the same length. So what if they just ask you for what one individual angle is? So like in my triangle, I shouldn't have erased it there. What if I ask you, hey, how many degrees is in each one of these little corners here of our triangle if it's a regular triangle, right, where all the angles are the exact same? Well, most of you know a triangle adds up to 180, and so if I want to know which angle, what angle measurement is for all of these, you can just divide it by how many sides it has, right? And that's what we're going to do on these questions. When it asks you to find each individual angle, they'll say, hey, how much is one angle measurement? Just one of them, right? Not the whole thing added together, not all 180 degrees. How much is each specific angle if it is a regular shape? Well, you just do the formula we just had, right? N minus 2 times 180. All you're going to do at the end is divide it. Big fraction bar means divide. Divide by how many sides it has. Just divide it by how many sides it has, right? So, for example, find the measure of one interior angle in a regular shape. In this case, a regular hexagon, right? Think about what a hexagon adds up to. Excuse me, let me rephrase that. Think about what a hexagon has for the number of sides. If you need to go back and look at my little chart from earlier, a hexagon has 6 sides. Let me fix that. I put a 2. It should have been an N. So what we're going to do is the same formula we did a minute ago, where we did 6 minus 2 times 180. But now, instead of wanting all of them added together, we just want one angle. So we're going to have to divide it by how many sides that it has. All right, so we'll do 6 minus 2, that's 4. We're going to do 180 times 4, get that answer, and then divide that answer by 6. And that's it. And this is where a calculator is going to be almost necessary because you don't want to have to do all this dividing by yourself. In fact, I'm not even going to work all these out because it would make me divide it. I can actually do this one in my head. This one is 120 degrees. But I don't want you guys to have to try to do it in your head or work it all out, right? For a 20-gon, you would do 20 minus 2 times 180. That gives you all of the angles added together, but we don't want all the angles. We just want one. So we're going to have to divide it by how many angles we have, and we have 20 of them, the number of sides that the shape has, right? And that one, you know, I could work it out if I really wanted to. It would be 18 times 180 divided by 20. And I'm not the best at doing that. I might actually be able to do that one in my head, but it's 9, so I think it's 162 maybe. I could be wrong on that. But don't try to do them in your head like I am, right? A decagon that has 10 sides, you'll do 10 minus 2 times 180, and then divide it by how many sides you have, divided by 10, right? And that's actually going to be, I don't know, something you can work out with the calculator. And then here a 14-gon, my 4 kind of got smeared off the page there. You would do 14 minus 2 times 180 divided by 14, how many angles we had. The number of sides that you have is also the number of angles that you have. So use a calculator to help you on these, right? This would be 12 times 180, and then whatever answer you get divided by 14. Sometimes you'll get decimals. That's 8 times 180 divided by 10. It's okay to get decimals. That is fine. Not going to be a problem if you have decimals at all. You can have that, and it is completely acceptable to have decimals. So don't have a panic attack if you get that. Okay? All right, I'm going to stop here. I'm going to put some questions on the on the McGraw-Hill site, and that will be a few review questions that we did last week, and then questions about this topic. Feel free to email me if you have any questions, guys. Have a good one.